Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of our 2020 AP Calculus AB Multiple Choice Practice Test Problems, Volume Number 1. Don't forget, we have 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate that you've mastered the contents of this tutorial. Alrighty. Let's take a look at question number 1. Question 11. In question 11, we're going to be assessed on how to evaluate the definite integral or utilization of the fundamental theorem of calculus, part 1. So how do we know that this is a definite integral? Well, because we have a definitive boundaries here. We have a definite lower and upper limit of integration. So that's how we know that this is a definite integral. If there are no limits to the integration problem, then we'll have an indefinite integral situation. Alrighty? Okay, so let's go ahead and evaluate this integral. So we're looking for the integral of from -2 to 2 of x to the third minus 2x over x dx. Alright, before we get started evaluating this integral, let's review FTC part 1 again real quick so we know exactly what we're going to do. So the formula for definite integrals, or FTC1, in some books is referred to as 2, but it doesn't really matter. It's just one of the fundamental theorems of calculus, is as follows. If you're integrating a function, let's say f of x from a to b with respect to x, what you're going to do first is integrate the function. The antiderivative can be represented with uppercase f of x. So you're going to evaluate the antiderivative from about the limits of integration. All right. So you evaluate the antiderivative at the upper limit minus the antiderivative evaluated at the lower limit. So these are the steps that we're going to implement in this problem. So step 1, we'll find the antiderivative of the integrand right here. That will give us uppercase f of x, and then we'll evaluate it at the limits of integration, namely -2 to 2. Okay? All right, so how do we integrate this integrand right here? Well, we're going to use Roper to help us out. So let's look at this and see which method can we use here. It looks like this is definitely a candidate for rewrites. We want to rewrite this integral. Okay, so how can we rewrite this integral? Well, we can decompose it into 2 algebraic fractions and then reduce from there. All right, so we have the integral from -2 to 2 of x to the third over x minus 2x over x. Alrighty, so we're gonna find that integral with respect to x. So let's simplify that. So we have the integral from -2 to 2 x to the third over x to the first power. Using the quotient property of exponents, you just subtract, right? When you're dividing exponents with the same base, you subtract the power. So we have x squared minus, and then these ones just divide out the x's, 2 dx. Now, why did we rewrite? Well, now we can apply the power rule in evaluating this integral, okay? So it's always convenient if you can express your integrand as a polynomial, and then you just use the power rule to integrate them term by term. All right, so let's go ahead and evaluate this integral right here. So when we integrate x squared, that'll give us x to the third over 3. And then when we integrate 2, that will give us 2x. So this is our uppercase f of x that we're talking about, the antiderivative. Okay, so we're evaluating the antiderivative from -2 to 2. So what we'll do is we'll evaluate this at the upper limit and then subtract from what we get when we evaluate it at the lower limit. Now, if we plug in the upper limit, 2 into the x's, what are we going to get? We're going to get we're going to get 2 to the third power over 3 minus 2 times 2. Okay, minus, and then we're going to plug in -2, the lower limit of integration, into this, and then we're going to have -2 to the third over 3 minus negative 2. Okay? All right, so if you take a look at the setting that we have right here, I deliberately made a mistake that many students make. Do you see what the mistake is? All right, so what is the mistake? The mistake is as follows. When you are subtracting, you're supposed to encapsulate the left part right here in parentheses, okay? So that without the parentheses, that will result in a sign error. So keep that in mind. It's a common mistake that many students make is they forget to put the minus and put the parentheses in front of the antiderivative evaluated at the lower limit. Okay? All right, so from here on out, it's just going to be arithmetic. We're going to PEMDAS this expression real quick. 2 to the third is 8. 8 over 3 minus 4. Let's write that as a fraction. Minus, and then negative 2 to the third power is going to be negative 8 over 3. And then minus minus plus 3. Plus 2. Okay. Oh, there was a 2 right here. I left it out. Okay, so that's the 2 right there. And then when you multiply those two together, you get 4. Positive 4. Let's write that also as a fraction. Okay? All right, so the reason I'm writing everything as fractions is I want to find the LCD, and then it will make it easy to evaluate what the resulting expression is. Okay, so the LCD of 3 and 1 obviously is 3. So the fractions without 3 in the denominator position, we'll multiply those by 3. So multiply this by 3, top and bottom. Likewise, this one right here, the 4. And then while we're at it, we can distribute the minus sign to this fraction to the right. Okay, so we have 8 over 3 minus 12 over 3 minus times minus makes this a plus, plus 8 over 3. And then minus times this minus makes that a minus, minus 12 over 3. Alrighty, so if we go ahead and evaluate this, basically going to have 8 plus 8 is 16 minus 24. 16 minus 24 over 3. That would give us negative 8 over 3. And that, ladies and gentlemen, is the answer to question number 11. So answer to question number 11 is option letter A. All right, so in this example, we highlighted one common mistake that students make, which is forgetting to put the parentheses. Well, what is another common mistake that you think students can make when solving this problem? Let us know what you think in the comment section below for the benefit of those watching this presentation. Thank you. Alrighty, let's take a look at question number 12. In question 12, we're going to be looking at the mean value theorem. Alright, so this problem focuses on using a table to see what intervals satisfy the conclusion of the mean value theorem. Alrighty, so let's go ahead and review what the mean value theorem is again. So we'll look at that first, the mean value theorem, and then we're going to use it to solve the problem. All right, so the mean value theorem is as follows. If a function f is continuous on a closed interval AB and differentiable on a open interval AB, then so this is the hypothesis, okay? The initial condition, you need a function that's continuous and differentiable on these intervals. Then there exists a C in this interval, open interval AB, such that the slope of the tangent line f prime of C, like we have here, is equal to the slope of the secant line, f of B minus f of A over B minus A. The slope of the secant line on the interval containing that C value. Okay. All right, so problem 12 says the table above gives selected values for the differentiable function f. In which of the following intervals must there be a number such that f prime of c is equal to -1. Okay. All right. So here, remember this right here. The derivative of the point is the SOT, slope of the tangent line, and over here, if you're looking for the slope of an interval, is the slope of the secant line. So the mean value theorem is basically telling us that there is a point where the slope of a tangent line is equal to the slope of a secant line as long as the function is continuous and differentiable. All right, so this function is differentiable, so that automatically implies continuity. So it satisfies the hypothesis of the mean value theorem, so we're just looking at the conclusion. Alrighty, so what we're going to do is basically test which intervals would generate an SOS that is equal to -1. Why are we looking for -1? Well, because our SOT, the slope of the tangent line, is equal to -1, so we're looking for which interval satisfies this conclusion here. Alright, so let us start with option letter A. Alrighty, so option letter A, we're going to test the interval 0, 3. What on earth does that mean? Well, this basically means that our A is going to be 0 and our B is going to be 3, and we're going to see if the slope of the secant line is equal to -1. All right, so let's do it. So we're looking for f of B minus f of A. So f of B says f of B is f of 3 minus f of A divided by b minus a, like that. All right, so using the table, f of 3 is 0 minus, so f of 3 is 0. F of 0 is -3. 0 minus -3 over b minus a, which is just 3. All right, so this becomes 3 over 3, positive 1. Ladies and gentlemen, on this interval, the slope of the secant line is 1, and that's not equal to -1, so that's not the answer we desire. So what do? Move on to the next interval, B. We're now going to test 3, 6. All right, so that basically means that A is going to be 3, the lower bound of the interval, and B is going to be 6. So let's look for the slope of the secant line on that interval. F of B minus f of A divided by b minus a. Okay, so f of B is 6 minus f of A, that's 0. Using the table, okay, 6 minus 3 is 3. And then we have 6 over 3, which is equal to 2. Ladies and gentlemen, this is not equal to -1, so this is not the answer. All right, so remember, we're looking for the SOS that's equal to -1. All right, so we have 2 fails so far. All right, we're going to move on to the next option. Fail, fail, option C. So for option C, we're testing the interval 6, 9. So we're going to test the interval 6, 9. What does that mean? Well, that basically means that A is 6 and B is 9. Okay. All right, so let's go ahead and find the slope of the secant line on this interval. So we have f of B, which is 9, minus f of A, which is 6, divided by b minus a. Okay, 9 minus 6. Let's work this out. So f of 9 using the table is 3 minus f of 6, which is 6, divided by 9 minus 6, which is 3. 3 minus 6 is -3 over 3, which is equal to -1. Ladies and gentlemen, we have a winner. Why is that the winner? Because the slope of the secant line on this interval, 6, 9, is equal to the slope of the tangent line, and that satisfies the conclusion of the MVT. So the answer to option number 12 is letter C. Alright, so in this particular problem, we used a theorem called the mean value theorem. Now, have you ever wondered where this word mean comes from? How does this word mean apply to the mean value theorem? If you know what the answer is, just specify it in the comments section below. We'd like to know. Alrighty. Let's take a look at question number 13. On question 13, you're going to be assessed on how to find finite limits. Okay, so let's go ahead and attack the problem. So we want to find the limit as x approaches 0 of 6x over 2e to the x minus 2. Alrighty, so when you're looking for finite limits, first of all, how do you know this is a finite limit? Well, you look at what x is approaching. If it's plus or minus infinity, then it's an infinite limit. There's a different set of rules for solving those kind of limits, but if you're approaching a number, a finite number, then it's a finite limit. Okay, so we're going to sally this problem real quick. First step is to substitute and see if we can get the answer. So let's substitute. When we substitute, we're going to have 6 times 0 divided by 2e to the 0 minus 2. Alrighty, let's go ahead and work this out using our order of operations. Multiply the numerator, you get 0, and the denominator, e to the 0 is 1, so you have 2 minus 2, which is equal to 0 over 0. Alrighty, so what on earth is this? Is this undefined or something else? Now, if the answer were undefined, then we are going to say option D is the answer is non-existent. But this is not undefined, okay? This is known as an indeterminate form. Indeterminate. What does that mean? It means that the limit cannot be determined in this particular format. Alright, so remember, indeterminate is when you have 0 over 0. That's one of the indeterminate forms. There are other ones you come across in Calculus 2 and beyond. For AP Calc, this is one you come across. But undefined, remember, so note, let's put a side note here. You want to note that undefined is where you have a non-zero number divided by 0. All right, when you've had for example, you have 3 over 0. Now in cases like this, the limit does not exist, D and E. Alrighty, so this is not undefined, it's indeterminate. So when you're finding a finite limit and you end up with an indeterminate form, how do you proceed? Well, you can either use algebraic manipulation or L'Hopital's rule to rewrite the limit into a form that you can determine what the limit is. All right, so that's the A and the L of our Sally, I for indeterminate form. So what we're going to do is we're going to use L'Hopital's rule. We're going to use L'Hopital's rule. Let's review that first. What on earth is L'Hopital's rule? L'Hopital's rule is a convenient way of finding limits of an indeterminate form. So this is what it says. If you're looking for the limit as x approaches a of f of x over g of x, it is the same thing as looking for the limit as x approaches a of the derivative of the numerator divided by the derivative of the denominator. All right, so that's what we're going to do with this problem. We're going to use L'Hopital's rule. All righty, okay, let's do it. So we're going to go the limit as x approaches 0 of 6x over 2ex minus 2. So since it's indeterminate, we're just going to differentiate the numerator and the denominator, and we'll sally it again. All right, so let's do it. So if you differentiate, we're going to have a new problem. Limit as x approaches 0. Derivative of 6x is just 6. Derivative of 2e to the x is 2e to the x. Remember, the derivative of e to the x is just e to the x, right? And then the derivative of 2 is 0. Okay, so we have a new problem. Now we're just going to sally it. Again, just substitute first. What do we get? We substitute, that's going to give us 6 over 2e to the 0. So that's going to be 6 over 2 times 1. Remember, e to the 0 is 1. And then 6 over 2 is 3. Ladies and gentlemen, the answer to question number 13 is option letter A. Alrighty, so that's basically how you use L'Hopital's rule to find finite limits. Alrighty, let's take a look at question number 14. Question number 14, we're going to be looking at position, velocity, and acceleration problems and the indefinite integral. Question 14 reads, a particle moves along a straight line so that at times t greater than or equal to 0, its acceleration is given by a of t equals 18t. At times t equals 0, the velocity of the particle is 4 and the position of the particle is 7. Which of the following is an expression for the position of the particle at times t greater than or equal to 0? Alright, so what's going to guide our problem solving process here? Well, we're going to be using CEVA to help us to solve this problem. Alright, so let's go ahead and take a look at CEVA real quick. So we have position, velocity, and acceleration. When you're going down this continuum from position to velocity, you're differentiating with respect to time. And then when you go one step from velocity to acceleration, you differentiate again with respect to time. Okay? So differentiate when you're going down. Now when you're going up from acceleration to velocity, you do the inverse operation, which is integrate with respect to time. Of course, you add your c, the constant for indefinite integration. And then when you're going from velocity to position, you're going to integrate and then with respect to time, and you add c. In this particular problem, you're given the acceleration function and you're asked to find the position x of t. So you can clearly see that we're going to be implementing the integration operation to work our way up from a all the way to x. Alrighty, so let's get started by finding the velocity first as our first stop, and then we will conclude by finding the position. So let's find v of t. Alrighty, so starting from acceleration, we know that the acceleration function is 18t. So the velocity, as we can see from our guide over here, is the integral of our acceleration with respect to time. So we're going to integrate 18t dt. Alrighty, so if we integrate that, we're going to get v of t equals 18t squared over 2 using the power rule for integration. And don't forget that c, because this is an indefinite integral problem. Alrighty, so we have that. We can simplify that to become what? 2 goes into 18, 9t squared plus c. So let's go ahead and write that down. So v of t is equal to 9t squared plus c. So this is the general solution for v of t, okay? So to find a particular solution, we're going to make use of the initial value that we were given. In the problem, we're told that at t equals 0, the velocity is 4. So what does that tell us? Well, that tells us that v of 0 is equal to 4. So this initial condition can help us to solve for c. The 0 goes into the t spot, and then the 4 goes into the v of t spot, like that. So when we make that substitution, we're going to have the equation 4 equals 9 times 0 squared plus c. Okay, so if we solve that equation, what is that going to give us? That's going to give us the answer c is equal to 4. Okay, so that follows that our velocity function, v of t, we'll plug it into the general solution. V of t is equal to 9t squared plus 4. Alrighty, so we have an answer here, 9t squared plus 4. Is that the answer? No, that's a distractor. That's not the answer. The problem says to find the position. All right, we're just halfway there. We need to integrate again to find the position. This is just the velocity. So we're going to repeat the same steps again. So now we're looking for, we want to find the position function. Alrighty. Starting from velocity, we know that that's 9t squared plus 4. We're going to find the position. How do you find the position from velocity? If you look at Siva right here, you can see that you just integrate, right? All right, so we're going to integrate the velocity function to find the position function, the general position function. So we're going to integrate 9t squared plus 4. So our position function is going to be, if you integrate 9t squared, you get 9t to the third over 3 using the power rule plus 4t. Okay? How does this look? Ladies and gentlemen, anytime you're evaluating an indefinite integral, you have to include the constant. All right? Because when you integrate 0, you get a constant, right? So that's why you have that C piece right here. Oh snap, I forgot to put the dt. It's important. Okay, so there you have it. Now this is a general solution for the position function. To find the particular solution here, we don't have any plus c's here. We're gonna make use of the initial condition, which is that at time t equals 0, the position was 7, so x of 0 equals 7. So we're going to replicate exactly what we did here, right here. So you take the 0, that's our t value, plug it into t, and then you take 7, and oh snap, so the 0 goes into that t and also this t here. And then the 7 goes into this whole x of t position right here. So when we make our substitution, we're going to have 7 is equal to 9 times 0. All this is going to be 0, but let me just show you the work, okay? So 4 times 0 plus c. And this automatically follows that c equals 7. So, ladies and gentlemen, our position function, x of t, is what you get when you put in that 7 into the general position function. To get the particular position function, we can divide the 9 by 3. So that reduces it to 3t to the third plus 4t. And then substitute this 7 here. Plug it in right here, okay? That's what we did before. We're doing the same thing again. Plus 7. Ladies and gentlemen, the answer to question number 14 is option letter A. Let's go ahead and box that. Alrighty, ladies and gentlemen, this is one way of solving this problem. There is also another way of solving this problem. Hint, it starts with an F. So if you know another way of solving this problem, it's pretty elegant. Just specify what the answer is in the comment section below. Let's see if you can get it correct. Alrighty, let's take a look at question number 15. In this one, we are going to be assessed on continuity and differentiability, okay? Establishing if a function is continuous or differentiable at a specified x value. So it reads, let f be the function above. Which of the following statements is true about f? So we're looking at, are they continuous? Is it at 3 or differentiable, or neither of them applies, and is it defined? All right, so let's go ahead and review what continuity and differentiability means. Also, what does it mean for a function to be defined? So a function is defined if f of x, defined at if f of a exists. So everything is going to be at a, okay? So f of a exists. So if you look at your graph and f of a cannot be mapped, you can map the input a to a particular output, then f of a is undefined, alrighty? So how about continuity? How do you know if a function is continuous? You know that a function is continuous if the left-hand limit is equal to the right-hand limit. This means that the limit exists and that it is equal to the value of the function, which is the defined component of that. So at a is basically if the limit as x approaches a of a function is equal to f of a. All right. Okay. And then differentiability. How do you know if a function is differentiable? Well, it cannot have a corner cusp, vertical tangent, or discontinuity. All right. So the simple way to determine if a function is differentiable, the number one condition is, first of all, it has to be continuous, and the right-hand derivative has to be equal to the left-hand derivative. Basically, f prime of a from the right is going to be equal to f prime of a from the left. So this ensures that you don't have anything like a corner cusp or a vertical tangent at a. Alrighty, so these are the 3 points that you want to keep in mind for this problem. Okay, so first and foremost, we want to see, it says f is continuous and differentiable. F is continuous but not. Let's start with continuity first, okay? Or no, let's see if f is defined. So f defined at x equals 3. So we don't know yet. Let's ask it as a question. Is f defined at x equals 3? So basically, does f of 3 exist? So what is f of 3 in this particular problem? So to help us with this, when you're dealing with piecewise defined functions, sometimes it's beneficial to use a number line to give yourself a visual as to what's happening where. So we have our number line right here, and we're looking at what's happening around this point, namely 3. All right. So this interval right here to the left is where x is less than 3. Okay, so which function is active there? 3x squared plus 1 is not only active for x is less than 3, but also for x equals 3. So for the value of the function and anything smaller, we're going to be looking at this guy right here, this quadratic binomial. Bam. And then, let's call that interval 1. And then for interval 2, namely where you are just to the right of 3 excluding 3, what's live is going to be this linear function right here, 2x plus 22 for x greater than 3. Alrighty, and then this one for x equals 3, we're going to be using the same function, the blue function. Okay, so for is f defined at 3? Well, what is f of 3? F of 3, we have 2 functions here to select from. This is function 1 and this is function 2. Obviously, we're going to be evaluating, we're going to be using function 1, okay, evaluating 3x squared plus 1 at x equals 3. Why do we pick that one? Well, because of this inclusion line on the inequality symbol. All right, so equals means that 3 is included, hence this function is what we use for x equals 3. Alrighty, so if we do that, it's going to be 3 times 3 squared plus 1, and we PEMDAS this real quick. 3 squared is 9 times 3, that's 27 plus 1. Bam, ladies and gentlemen, f of 3 is defined. So we can now move on to continuity. Is the function continuous? All we just have to do is find the left-hand limit, the right-hand limit, and see if they're both equal to this value right here. So next question is f of x continuous? Is f of x continuous at x equals 3? Okay, so let me just rewrite what we're trying to show here. We're asking the question, is the left-hand limit equal to the right-hand limit equal to the value of the function, which is 28? That's the question that we're asking here. Okay, so let's go ahead and do that. So the left-hand limit is the first one we want to calculate. The left-hand limit is the limit as x approaches 3 of the function. So in this interval that we have right here, if you're approaching 3 from, sorry, I left something out. X approaches 3 from the left. That's what we are looking at. So when you're approaching 3 from the left, you're in interval 1, okay, because you're from the left. This is 3 from the left. So we're going to be using this function again. So limit as x approaches 3 from the left of the function is basically going to be 3x squared plus 1 evaluated at x equals 3. Okay, and we already did the calculations. That's going to yield 28. It shouldn't be a surprise because it's the same function for the left-hand side of 3 and for 3. Okay, now let's go ahead and look at the right-hand limit. All right, so for the right-hand limit, what do we have? For the right-hand limit, we're going to be looking for the limit as x approaches 3 from the right of the function. So to the right of the function, we're looking at the green function right here. So we're looking at this linear binomial evaluated at x equals 3. So that's going to be 2 times 3 plus 22. If we PEMDAS this, 2 times 3 is 6 plus 22, which is equal to 28. So since the value of the function, this guy right here is the value of the function, and the left-hand limit and the right-hand limit are the same. What does that mean? Ladies and gentlemen, it means that f is continuous, okay? F is continuous because the double-sided limit, which is a combination of the left-hand and the right-hand limit, which we can write together like this, is equal to 28, the value of the function. So, ladies and gentlemen, the function is defined and continuous. Okay, so let's move along to the last part. Let's see, can we eliminate any here? Yeah, we can eliminate option D because it says it's neither continuous nor differentiable. So the next question we want to ask is the question of differentiability. All right, is the function differentiable? We've already established continuity, so that's good. So we're just going to focus our attention on the left and right hand derivatives. All right, so part 3 is f differentiable at x equals 3. So the question we're asking here is f continuous, and is the right hand derivative equal to the left hand derivative? Ladies and gentlemen, we have already established continuity over here. Okay, so we're just going to focus on the left and right hand derivatives. So let's start with the left hand derivative. Left hand derivative is going to be f prime of 3 from the left. Okay, so what we're going to do is the function to the left, you just differentiate it and evaluate it at 3. So it's going to be the derivative of 3x squared plus 1 evaluated at x equals 3 because it's to the left. If you differentiate that, you're going to have 6x plus, just 6x. All right, 6x evaluated at x equals 3. So that's going to be 6 times 3, which is 18. Ladies and gentlemen, the left-hand derivative is 18. So let's see what the right-hand derivative is. F prime of 3 from the right. So we're going to use a function on the right, the green function, okay, the linear binomial. So 2x plus 22 prime. We're going to evaluate that at x equals 3. So you differentiate the function on the right for the right-hand derivative and the function on the left for the left-hand derivative. So what do we have? When you differentiate this, we're going to have, what are we going to have? 2. The derivative of 2x is just 2, evaluated at x equals 3, which is 2. They're different. So since the left-hand derivative and the right-hand derivative are different, since f prime of 3 from the left is not equal to f prime of 3 from the right. So we kind of have a corner situation, okay, kind of sorta. What does this mean, ladies and gentlemen? It means that f is not differentiable at x equals 3. Okay, so it's continuous and not differentiable. So let's see what the correct answer is. The correct answer to question number 15 is option letter B. F is continuous but not differentiable at x equals 3. Okay, so that's the answer. Now I have a question for you. Is it possible to have option C as an answer? Is it possible for a function to be differentiable and not continuous? Let us know in the comment section below what you think the answer to that question is and why. Alrighty, it's now your turn to do some practice problems. Now we have 5 practice problems that we'd like you to try out. So what you have to do right now is go ahead and pause this video presentation at this time. Try out these 5 problems, and when you're done, click on the playback button and we're going to reveal what the correct answers are. Alrighty, welcome back. So hopefully you had a chance to try out the practice problems. Let's take a look at what the solutions are. For question number 1, the answer is C, 8/3. For number 12, or number 2 or 12. For number 12, the correct answer is D. For number 13, the correct answer is, is D. For number 14, the correct answer, the position function is D, 3t cubed plus 3t plus 6. And then for number 15, the function is continuous and differentiable at x equals 3. Your answer is A. Alrighty, ladies and gentlemen, how well did you do in these 5 practice problems? Let us know your score in the comment section below. And if there are any questions you have with our answers or the processes, let us know. We'll be glad to assist you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your AP Calc exam or course, to give us a like or thumbs up. Your positive feedback is very helpful to us. Do not forget to subscribe to our channel. Tons of support resources for your calc class can be found on mathgotserved.com under AP Calculus. Do check it out. And if you have any comments or questions, you can specify it in the comment section below, and we'll be more than glad to respond. Thanks again for watching and have a wonderful day. Goodbye.